other direction. Executives of a supermarket chain are interested in the amount of time that customers spend in the stores during shopping trips. The executives hire a statistical consultant and ask her to determine the mean shopping time of customers at the supermarkets. The consultant will conduct a random sample of shopping times at the supermarkets and use the mean of these shopping times to estimate mu. Assuming that the standard deviation of the population of shopping times at the supermarkets is 26 minutes, so this is, the standard deviation is 26 minutes. What is the minimum sample size? So the question here is, what is the minimum sample size? So you are looking for n. You're looking for n, okay? The formula that we've had was the critical z times, and remember this is times right here, sigma, standard deviation, over the square root of n, less than or equal to the estimate. This is the margin of error, E equals 3. So plugging that in, and with a little bit of algebra, this formula becomes n equals critical z times sigma over the margin of error and then squared. So using that formula, n equals critical z times sigma over the margin of error squared, and plugging in the numbers from our problem, sigma is 26, 1 minus alpha is 1 minus 0.90 is 0.10. So alpha is 1 minus 90 is 0.10. So on the ALEKS calculator, you can get z of 0.10 over 2, which is 0.05. So this is z of 0.05 equals 1.645. So you'll plug that into the z, the 26 in for sigma, the 3 in for E, so you get 1.645 times 26 over 3, and take all that squared. So 1.645 times 26 and then divided by 3 is 14.257. Then you're going to square that and you end up with 203.2572. So since you cannot have a partial shopper, we always round up. And that is always. You do not round these mathematically, because if you were to take this down to 203, that would go below the minimum. So you would no longer have enough to give that margin of error. Okay? So your formula is right here. Just grab the numbers, plug them in. So this is for minimum sample size.